Hey, good evening. Today, we are going to finish up our Unit 3 notes, and we're going to do that by taking a look at mutations. So mutations, and right at the end, then, we're going to talk about something that I think is pretty fun called the wobble. But mostly, we're talking about mutations today. So mutations are changes in the genetic material. So I'm going to bring that up a few more times today. The genetic material, remember, that's DNA. The genetic material is DNA. So mutations really happen at the genetic material, at the DNA level. We don't care as much when the mRNA gets mutated or changed, not as big of a deal. It's really the original, which is the DNA. That's where we're really concerned about or really interested in mutations happening. Very specifically, we're going to work, at least today, with what we call point mutations. So point mutations occur at just a single nucleotide. 1A, T, C, or G changes into something else or changes altogether, and that's a point mutation. Later in the year, we're going to talk more about chromosomal mutations, entire chromosomes or parts of chromosomes that can get mutated. But for right now, we're just going to talk about individual point mutations, which are mutations that happen at just one nucleotide. All right, so we're going to start off by taking a look at a normal unmutated strand. Here's the normal strand. Okay, now, first thing to point out, you can tell I'm working in RNA and not DNA because I've got a U in there, a couple of U's actually. And DNA doesn't have U, instead it has T's. So I'm already kind of jumping ahead. I'm not doing the transcription part, so I'm not going from DNA to RNA. And I'm just starting off with our RNA strand. But remember, the mutations we look at will have happened in the DNA, not the RNA. I'm just kind of skipping a step. Second of all, you guys will notice I broke everything into groups of 3 letters. That's because our amino acid code comes from 3-letter words, nucleotide words called codon. So every 3 letters is a new word that codes for its own specific amino acid. Also, you'll notice I started with AUG. Remember, this is our start codon. AUG, it codes for methionine, and that is our start codon. Remember, never start translation until you read AUG. So let's go ahead and get started there. So this is our amino acid, our normal amino acid sequence. This one's going to be methionine, MET. Let's see, GCC. Here in the middle of just GCC, alanine, that's my favorite. UGC, U out to G out to C, cysteine, so CYS. AAA, lysine, LYS. CGC, arginine. And UGG, tryptophan. All right, so there is our normal unmutated strand of RNA and the normal nucleotide, or I'm sorry, the normal amino acid, so the normal protein sequence that we have that goes with it. All right, so our first type of point mutation, we actually have 3 types of point mutations. The first one is called a substitution. And now here's kind of the jump at you. Okay, we've got 3 types of point mutations, and actually substitution has 3 types of subcategories. So we're going to go A first, and we're going to look at what we call a silent substitution. So the first type of substitution is a silent mutation, and let's take a look at this one. So we still have AUG, haven't had that mutation yet. Then we go GC, and we'll skip over that one. Actually, let's just put it in right now. I want to change this C here to a U. Boy, I did that in a red pen, but you can't tell it all. Okay, let me see if I can't find a different color that might stand out a little more. Maybe that green will show up a little bit better in the future, but there's our mutation. See, it was a C, now it's a U. And that's, again, it's just a point mutation, so that's the only place that we have a mutation at. Everything else should remain the same. There we go. Again, we get our codon wheel back out. AUG, that's going to remain the same. That's still the same. MET. But now we have GCU. Oh, excuse me. Okay, all right, excuse me. So GCU also codes for alanine. GCC and GCU both code for alanine. So we actually don't have a change in our amino acid. And that's why this one's called a silent mutation. There is a mutation, there is a change, but there's nothing new. It's still going to be the exact same protein. Hey, not a very big deal, huh? All right, our next type is what we call a missense mutation. We still have AUG and then GCC. So we're going off this one as original. And then our mutation here occurs right there. So now we have this U becoming a G, mutating into a G. Okay, we're just working with a point mutation, so that's just at one particular spot. We don't need anything for that. Nothing's changed. Nothing's changed. Aha! Here is our new sequence. So now we're looking for GGC. That's going to be glycine, which is different than cysteine. We had cysteine, and now we have glycine. I'll do that in the green. Maybe it'll show up still. So glycine, there's our new different amino acid. Now after that, everything stays the same. Still have AAAs, still have CGC. So one amino acid changes. It's called a missense mutation. Not the biggest mutation in the world. We're probably going to be all right, unless that was a very important amino acid. We could still very well be all right, but it did have a one amino acid change. And then finally, our third type of substitution is a nonsense mutation. And so this time we're going to mutate that C into an A, and everything else is going to stay the same. And no changes here. So far, so good. It's right here where we'll get that new codon. So it's a U GA, stop. Aha, we run into a stop codon that wasn't there before. Stop means stop. Translation is complete, and we stopped almost as soon as we got started. These guys will never get made. And so this is a pretty big mutation. If you have a mutation that results in a stop codon, you're not going to end up making the protein you need to make. We need all 6 of these to make our protein, and we have 2. So this is a pretty big mistake, a nonsense mutation. All right, our next 2 types. So that's our 3 types of substitutions. Now we're going to go back out to number 2. But before we get there, I want to give you guys an example of what we call a frame shift mutation. So normal, again, codons, 3-letter words. Such as the fat cat ate the rat. What we just looked at were substitution mutation. Again, we substituted one letter for another. This U became a G. We substituted a G for the U. This C became an A. We substituted the A for the C. Substitution. In general, substitutions are okay. There's our substitution. And in general, you still get the same, you still kind of know what the sentence is saying. Is it a little out of order? Yeah. It's a little messed up, but you're still seeing what the sentence says. The fat cat ate the rat. The fat, okay, it's not perfect. But a lot of times, again, unless you get like a stop codon, a nonsense mutation, you're going to be okay with a substitution. The next 2 types are frame shift. So I'm guessing you can probably take a good guess as to what these are. We have an insertion and a deletion. Let's say we delete that E. So we don't substitute another letter in, we just flat out delete it. I'm just going to kind of leave that blank there. Everything gets bumped down 1 letter. So that E is not there anymore, which means the F comes over here, which means the C in cat joins this 3-letter word. Because ribosome, it reads 3 letters at a time. It doesn't stop to think about leaving a blank, or this word makes sense and that one doesn't. And the entire reading frame gets shifted. So every amino acid after that, every word after that mutation is going to be affected. And that's kind of the downside of what we call frame shift mutation. So here's our frame shift. The second type again, the first type of mutation was a substitution. The second type we're going to work with is a deletion. And again, this time, here's our sequence. Instead of substituting this 3rd letter, we're just going to delete it. And then that moves everything over by 1. And our entire reading frame is shifted, which means every codon after that mutation. So again, here's that mutation. We deleted whatever letter was right there, was a C. Now it's gone. Now that codon is GCU instead of GCC. And everything after that also is now out of whack. So met is still the same. Our start codon's okay, but after that, everything's going to be kaput. GCU now, so starting in the middle, G, out to C, out to U. There's alanine. Okay, that one actually didn't change. My favorite amino acid there. Next up, we have GCA. GCA. Hey, there's another alanine. I like this mutation. That AAC, starting in the middle, A, going out to A, going out to C. asparagine, GCU. Hey, there's alanine again. Boy, I'm loving it. Finally, GG, not enough for a codon, a completely different protein. Just like this sentence here is completely different from the original, that frame shift mutation, that deletion, changed our entire reading frame. And now we just have, again, a completely different protein than what we were supposed to have. So deletion can be quite bad. And as you guessed, the third type of mutation, also a frame shift. This one's called an addition or an insertion. So this is where we add a nucleotide as opposed to deleting one. So still have our original, haven't had the mutation yet. And here's where my mutation is going to be. I'm adding a C. Oops, 4 letters, not 3. So we've got an extra letter there that G was never there before, and now it is. And once again, that's going to mess up the entire protein. So the very beginning of it's okay, but after that, CUG. CUG, got leucine. CAA, glutamine. ACG, threonine. CUG, leucine. And again, one letter here is not enough for a codon, but again, you can tell completely different amino acid sequence than what we originated with. So that just adding that one nucleotide threw off the entire frame. A frame shift mutation and insertion. Everything after that just kind of got thrown off. All right, so let's wrap this unit up here. All right, so mutations only happen in the DNA, not the RNA. And we don't really care if the RNA gets messed up. The RNA code is not nearly as big of a deal as the DNA originals. Things that cause mutations are known as mutagens. Mutagens, and there are a lot of different mutagens. I'm going to give you a small list, but quite frankly, this list could be a lot larger. Sunlight, you've heard if you go out and sit in the sun for too long, you can get all sorts of different problems. So wear sunscreen. Well, that's because sunlight is a mutagen. Also, X-rays, don't get too many of those in 1 year. They can definitely damage your DNA. Smoking, I think we've all probably heard, don't smoke. It's bad for you. Even some viruses can change your DNA. So there are a lot of different spelling issues. Lots of different mutagens in the world. Quite frankly, guys, it's impossible to avoid them all. So just do your best to be safe around things you know are mutagens and avoid as many as you can. But don't think too long and hard about it. DNA is going to get mutated. If it happens, it's okay. All right, I'm going to finish up today with what we call the wobble effect. One of my coolest things is kind of nature's defense against mutations. So we do kind of have a built-in defense. First of all, kind of throwing out a fact here that you guys are all aware of. Many of you guys answered this on your last test. So there are 20 different amino acids. Remember, amino acids make up the proteins. So there's 20 different amino acids. Well, codons are made up of 3 letters. For each codon or each letter of the codon, there are 4 options, right? A, T, C, or G. Come over the next one, A, T, C, or G. Come over the next one, A, T, C, or G. There are 64 different codons. So you guys can do the math here. 64 codons, but only 20 different words, amino acids, means a lot of codons code for the same amino acid. So for example, take a look at A, C, doesn't matter. You can change the last letter as long as you have A and C, you're always going to end up with threonine. You notice that? There's a lot like that. G, C, doesn't matter. G, U, doesn't matter. So there are a lot of different codons that code for the same amino acid. And so because of that, we call that the wobble effect. And the idea kind of with that is imagine is on a wobbly table. It's kind of wobbling all over the place here. And they ask you to, hey, pinpoint which amino acid it is. And you're like, well, it's wobbling, so I'm really having a tough time with this. Well, hey, if you're close, there's a good chance you're going to get the right amino acid. So that's the wobble effect, kind of nature's defense against mutations. I think it's really cool. So good luck studying for the exam. Exam should be next class period. Otherwise, hopefully these notes help, and we'll see you next time.